Hey guys, welcome to day 19 of 100 days of code. Today we're going to be learning more about turtle graphics, but we're also going to look at event listeners, higher order functions, state, and multiple instances of an object. And we're going to be using this knowledge to build a whole bunch of games. We're going to be making Etch-a-Sketch, one of my favorite childhood toys, and this game is going to allow us to use the up and down arrows to move our turtle forwards and back, and then we can turn our turtle clockwise and anti-clockwise to continue drawing. So we can use this to create circles or to create lines, and we can basically create drawings using our turtle program. In addition, we're also going to be making a turtle racing game where we will get to bet on the color of a turtle who will win the race. And then once we click OK to the pop-up, then all of our turtles go to the starting line and they start moving at a random pace. And then once the first turtle hits the right edge of the screen, it will be declared the winner and we will get to see if our turtle won or not. So at the moment, the red turtle is not looking like it's going to make it. I think the orange is probably, oh, the yellow's overtaking it. And there we go. We lose. The purple turtle was the winner of the race. So I hope you're as excited as I am to build these projects together. Once you're ready, head over to the next lesson and let's learn about how we can listen to keystrokes on the keyboard. Now, in order to be able to create a lot of the games that we've spoken about, we need a way of being able to listen to things the user does. Like when the user taps a specific key on the keyboard. And the code that allows us to do this are called event listeners. So if we look at the turtle documentation, you can see that there's a whole section on screen events, including listening to key presses or listening to a click or other things that you can listen to. So the important thing is this listen method. This allows the turtle screen to start listening and waiting for events that the user might trigger, like tapping on a key. I've gone ahead and created a new PyCharm project, which I've called Day-19, and I've created my main.py file inside the project. Now, the first thing I'm going to do is I'm going to import the turtle class and the screen class from the turtle module, and then I'm going to use them to create my Tim the turtle and also create a screen object. This is basically going to control the window when we run our code. So you saw it just flash just now. Now, in order to start listening for events, we have to get hold of the screen object and then tell it to start listening. And once it starts listening, we have to bind a function that will be triggered when a particular key is pressed on the keyboard. Now, in order to bind a keystroke to an event in our code, we have to use an event listener. So the one that we're going to be using is this onKey method. And you can see it expects a function with no arguments and also a key like the A key on your keyboard or a key symbol, so the space or up or down. So I'm going to say screen.onKey, and then I have to bind some sort of function to this method. So let's create a function and we'll call it move forwards. And all that this function is going to do is it's going to get Tim to go forwards by 10 paces. And let's not forget our colon here. Now, coming back to my onKey method, I'm going to say that when the space key, so the space bar, is pressed, then trigger the function move forwards. Now, here's a really important point. When we use a function as an argument, so something that is going to be passed in to another function, we don't actually add the parentheses at the end. The parentheses triggers the function to happen there and then. But what we want is we want this method onKey to listen for when the space bar is pressed, and only when that happens to trigger this move forwards function. Now, the final thing I need to do is to add the exit on click so that my screen doesn't disappear when I run it. And now what I'm going to try is when I hit the space bar, you should see my turtle move forwards by 10 paces each time. So we're now controlling our turtle using a keystroke. What we've essentially got here is a function that's being used as an input. Let's say we have a function called function A that takes some sort of input, and then we have a function called function B. We can actually pass function B into function A like this. So notice that when we pass a function as an input, we only pass the name without the parentheses at the end. But how exactly does this function on key work? Because it's kind of crazy to use a function as the input to another function, right? So I want to show you a quick example of passing a function into another function. And I'm going to use the calculator example that we did many, many moons ago, when we created a calculator that could take two numbers, add, subtract, multiply, or divide those numbers. So we've got our four functions here. Now, you don't actually have to write any of this out because it's quite tedious. I just want you to watch and listen. So let's say I create a final function, which I'll call calculator. And this function is going to take a n1 and n2, two numbers, but it's also going to take a function as an input. Now, inside this calculator function, I'm going to take the function name that was passed in and then call that function by adding the parentheses and then passing in n1 and n2. So now I have my calculator function, which can take any function as an input, and once that function has been passed in here, then that function will get triggered passing in n1 and n2. Let's return this result as the output, and then let's call our calculator function. Let's pass in some numbers, and let's pass in the name of a function. So now let's go ahead and save this into a variable and then print that variable result. So now when I run the code, you can see I get 5 printed. And that's because I've got add as the third input here. But what happens if I change this to multiply? Well, I get 6 instead of 5. And what happens if I put divide? Well, I get 0 because it's rounding up to a whole number. But essentially, what I'm trying to demonstrate to you is this concept, which is known in Python as higher order functions. And the idea of a higher order function is a function that can work with other functions. So in this case, our calculator is a higher order function because it's actually taking another function as an input and then working with it inside the body of the function. Now, there are certain programming languages where you can't do this at all, but in Python, this is pretty commonly used, and it's really useful when we need to listen for events and then trigger a particular function. Now, while we're on the topic of functions, I recommend that when you're using methods that you haven't created yourself, like for example onKey, to use keyword arguments instead of positional arguments, especially if, like in this case, the position doesn't actually have any meaning. So now that you've seen how event listeners work, we're going to be using event listeners to build out our Etch-a-Sketch program in the next lesson. So for all of that and more, I'll see you there. Now that you've seen how event listeners work, here's a challenge for you. I want you to build a Etch-a-Sketch app. This is what you're aiming for. You should be able to create a turtle that will allow you to press the W key to go forwards, the S key to go backwards, the A key to go counterclockwise or leftwards, and the D key to go right or clockwise. And then be able to draw things like this, or you could do up and right to draw curves like this. We're kind of creating that childhood game, which is Etch-a-Sketch. When you press the C key, it should clear all your drawings and put your turtle back in the center. So think about what you've learned so far about how event listeners work and then use the turtle documentation, read through the different methods that you have access to, and then try to figure out how you can get this Etch-a-Sketch program to work in the way that it's shown here. So pause the video and give this challenge a go. So this is the demo code from previously, and this is a really simplified version of how the event handlers work. So for example, we've got our move forwards function, which is going to be triggered when the space key is detected by the screen. And the screen is able to detect it because it's listening for those keyboard strokes and clicks. Now, because the onKey function can only receive a function with no arguments, at least this is what we see in the documentation, then that means we have to create 4 separate functions: move forwards, move back, turn left, and turn right. So now all I need is 3 more of these functions: move backwards, turn left, and turn right. Now I'm going to change this binding from space to W, which is going to be move forwards, and then I'm going to copy this and make 3 more of these so that I've got my W as move forwards, and then I've got my S as move backwards, my A as turn left, and my D as turn right. So now all we need to do is to actually create these functions. So let's create our move backwards, which is going to take Tim backwards by 10 paces. And then the next function we're going to create is to turn left. And this is going to get the current heading of our turtle and add 10 degrees to it. So if you imagine that the turtle starts out pointing towards east, and this heading is going to be 0. And we know that to point north, it becomes 90. So if we want this to turn leftwards, then we have to add to the current heading value, like this. So this could be our new heading. And then we can get Tim to set its heading to that new heading so that we turn left by 10 degrees each time. Now, you could have also used simply just the left function. So you could have said tim.left by 10 degrees. Both methods work, and it's totally up to you which one you choose. Now, in order to turn right, it's basically the opposite. So instead of adding 10 degrees, all we have to do is subtract 10 degrees. Or alternatively, calling tim.right, passing in 10 degrees. Now we have all 4 functions defined and tied to a keystroke. Let's go ahead and test it out. So W should take us forwards, S should take us backwards, A should turn left, and D should turn right. So perfect. Now the last thing we wanted to code in was some sort of way of clearing the screen. And we said we would bind that to the C key. So I'm going to create a function called clear, which I'll define here. And this function is going to clear the screen, wipe out all the drawing, and then take our turtle back to the beginning, which was at the middle of the screen. This is going to require a little bit of reading in the turtle documentation. If you scroll through this list, you'll actually find 2 clear methods. One is a method that is for the turtle, and another is a clear method for the screen, which is the window basically. Now this clear is going to clear everything. It's going to delete our turtle and everything else that's on screen. Whereas this clear, which is tied to the turtle, is just going to delete this particular turtle's drawings. So this is what we need to do. We need to get hold of Tim and then call clear on him to get rid of all the drawings he's made so far. Now the next thing we're going to do is we're going to bring our turtle back to the center, to the starting point. And this is going to be aided by one of the methods called home. So I found this in the documentation, and it says that it moves the turtle to the origin, which is in the middle of the screen. Now all we need to do is to call home And notice what happens if I run this as it is. So I can draw and basically make a mess. And then when I hit C, you can see it goes back to the home, but it's actually drawing its whole path back there as well. To prevent this from happening, we have to pull the pen up, which we've used before. And then once Tim has reached home, then we're going to put the pen down, ready for the next drawing. So now we can make a drawing, hit C, and then it goes back to the center. Did you manage to complete this challenge? Don't beat yourself up if you didn't manage to find some of the methods like home or clear. It's a matter of getting practice with reading the documentation and having the patience to go through it and look for the relevant methods. And on top of that, it's just a matter of messing around with the code. Try things out, see what happens. And each time you add something, run the code, see if it does what you want it to do, and if not, fix it. And that is the endless cycle of software development. So don't get frustrated if you got stuck. As long as you managed to make it work in the end, and you've learned some lessons from this process, then you can congratulate yourself on completing the job. And I find that I always learn more when I make more mistakes and when I struggle more. Once you're done playing around with the code, head over to the next lesson, and we're going to be learning about object state and creating multiple instances of the same object. So for all of that and more, I'll see you on the next lesson. The objective is we want to be able to build a turtle race where we have multiple turtles to run along a line and then see who actually reaches the finish line first. Now, here's a question though. We know how to build one turtle from the turtle blueprint, but what if we need more turtles? How do we get hold of them? Well, we know that we can use a class or a blueprint to define what a turtle should appear like and how it should behave. So what it has and what it can do. Now we can then take this class and construct an actual turtle object from it, which is then doing all the drawing and walking around on the screen. So this is what the code has looked like so far. We have Timmy, which is our turtle object, and turtle, coming from the turtle module, is the class which is used to construct this object. But that's not the end of the story, because the whole reason why we can have these blueprints is so we can make more objects. So we're not limited to just one turtle object. We can create as many as we need. In the same way that we have created Timmy, we could create Tommy, Johnny, Jenny, and Benny. Even though both Timmy and Tommy are turtle objects, they actually function completely independent of each other. So in programming, we would say that they are each a separate instance. So what does that mean? Well, that means that they're each an example of the turtle object. So just as you and I are both examples of human objects, Timmy and Tommy are both examples of turtle objects. And that means that at any moment in time, they could have different attributes and they could be doing different things. So that means, for example, Timmy could have its color set to green, while Tommy could have its color set to something completely different, like purple. Now, the fact that each of these objects can have different attributes and can be performing different methods at any one time in programming is known as their state. So the state of Timmy's color attribute is green and Tommy's color attribute is purple. So in this case, they have different state in terms of their attribute or their appearance. But they can also have different state in terms of whether if they are doing something. For example, Timmy could be asked to move forwards while Tommy is staying completely stationary. So Timmy's in the middle of a method call, whereas Tommy is not doing anything at all. Now in the next lesson, we're going to be building out our turtle racing game, and we're going to see this in action. The idea that you could have separate versions of the same object, each with a different state and acting completely independently from each other in order to race against each other. So don't worry if this doesn't make sense 100% just yet. Head over to the next lesson and we're going to start writing some real code to better understand this concept. Alright guys, in this lesson we're going to be building out our turtle race. And through building this race we're going to get more familiar with these concepts of state and instances. And that's because we need to create multiple turtles to join our race. This is what we're aiming for. In the beginning, there's going to be a little pop-up that will ask us to bet who will win the race. And it asked me to choose a color. Now, the turtles are in the color of the rainbow, so I'm just going to pick the red one. Once I hit OK, we have all of our turtles lined up in the starting position, and they will start making random steps towards the right edge of the screen. Now, the first turtle that reaches past the right edge of the screen is going to be the winner. And at the moment, it looks like the green turtle is probably going to get there first. There we go. So as soon as a turtle crosses the finish line, then it will print out a line telling us whether if we won or whether if we lost our bet and which turtle won the game. So this is the goal. Now I'm going to get started by deleting all of the code inside our previous Etch-a-Sketch project other than these few lines. So I've got Tim, my turtle, screen, which is a screen object that is going to hold the screen until I click on it so that I can see what's going on. Now, because in this game, the dimensions of the screen or of the window is really crucial, I'm not just going to get the default screen size show up. Instead, I'm actually going to use one of the methods that is in the screen object, which is called setup. And setup, as you can see, allows me to set up the width and the height of this window that's going to show up. So I'm going to set the width of my screen to 500 and the height to 400. So I should end up with a 500 pixel wide, 400 pixel high screen. And once I hit run, you can see this is what it gets resized to. Now, if you came across this code and it was somebody else's code, then these numbers and their positions don't actually make a lot of sense. Which one's the height, which one's the width? So in these situations, I recommend using keyword arguments rather than positional arguments. So let's write out the parameters explicitly. Our width to be 500 and our height to be 400. This way, when somebody else comes along and reads your code, it's a lot easier to understand rather than just 500 and 400, because it could be both ways. So now that we've got our screen set up, the next thing I want to do is to bring up that pop-up and ask the user to make a bet. Now, if we take a look at the Python documentation, where we've been spending a lot of time recently, you can see that there is a method on the screen which is called text input. And this is going to show up a pop-up window and it allow the user to look at the prompt and the title and to enter a piece of text. And if you want the user to enter a number, then you would use num input. So let's go ahead and add that here. So it will be a method from screen, which is called text input. And then it's got two parameters. One is the title, which in my case, I'm just going to say, make your bet. And then the second parameter is going to be the prompt. And in my case, I will probably say which turtle will win the race and tell them to enter a color. Now this works really similarly to our input, which we've been really used to, because it will return the string and we can catch that string inside a variable. So we'll call it user bet and we'll set it to equal the output from this method. So now let's give this a shot. Let's run the code and then let's enter a color, hit OK, and if we take a look in our console, you can see that that bet string is printed in here. So now the next thing we're going to do is we need to do something with our turtle. So I'm going to move it down a little bit. And what I want my turtle to do is I want it to go to the start of the line. So the very left edge of my screen. Now I could, of course, just say tim.backward by however many paces, But thinking forwards and knowing that I'm going to have 6 or 7 of these turtles, I can't just tell them all to go backwards because they're going to go to the same position. Instead, we're going to use a method that the turtle has, which is called goTo. And this allows us to define an x value and a y value. But how do we know what x and y values to give it? Well, we first have to understand how the Python turtle coordinate system works. So if you imagine your program window as a graph, where the center of it is at the coordinate 0, 0, well then if you have a window that has a height of 400, then that graph will have a y-axis that extends from the center at 0 all the way up to the top edge, and then from the middle it goes down to the very bottom edge, which is going to be negative 200. So 200 plus 200 makes up 400. And the same happens with the x-axis. So if the width of the screen is 500, the x-axis goes from the center 0 to positive 250, so half of 500. And then from 0 to minus 250. So here's a question. Let's say we wanted to move our turtle here. What do you think would be the x and y coordinate of that point? Okay, so let's say that this is roughly halfway on the x-axis and about halfway on the y-axis. Then half of 250 is 125 and half of 200 is 100. So this point would have the coordinate of 125 by 100. If we wanted our turtle to go all the way to the left side of the screen, say maybe starting over here or starting over here, well then we would have to use that goTo method and then specify a x value and a y value. Following the logic of the turtle coordinate system, then in order to move our turtle to the very left edge, then we should supply an x value of minus 250, which is half of the width of 500. Now the y value will determine where on the y-axis our turtle moves to. So if we had it at 0, then it would basically just go straight backwards and it would not go up or down. But let's say that we put it at minus 100. So now if I run this code, you can see that it goes in the right direction, but it's actually gone off the screen. So what's happened here is that minus 250 is on the very, very edge of the window. And once our turtle moves over there and the arrow is at the back, then you can't actually see it at all. So let's try changing that x value and shifting our turtle a little bit more to the right. Then you can see it moves to pretty much the start of the window. So I recommend using this goTo method and trying out some different numbers just to see where it ends up on the screen. And once you put in some different numbers in here, you'll start to get the hang of how this coordinate system actually works. But just remember that the x-axis is along the horizontal. It goes from 0 to positive and 0 to negative. And then the y-axis is along the vertical, going from 0 to positive and 0 to negative. So we want to get rid of this line, and we don't actually want our turtle to draw at all. So to do that, we're going to do tim.penup, and we're actually never going to put the pen down because we're going to be moving the turtle itself. And the other thing is that it would be really nice if instead of an arrow, we actually got a turtle. So we can of course say tim.shape and set it to a turtle shape, but here's an even easier way. When we create a new turtle, look at the prompt that it's giving us. It's actually giving us a way to initialize a new turtle object already with a shape set up. Now, this shape is set to have a default value, which is basically the arrow, but we can also specify the shape and give it the turtle shape to begin with. Now, when I run the code, you can see that firstly, I get a turtle shape, and then the pen is up and I'm not drawing, and then it moves to this place on the graph, minus 230, minus 100. So now the next thing we want to do is to be able to create lots of turtles, right? What if we had all of the colors in the rainbow and we create a turtle for each color? So there's 6 colors in this list, and these of course correspond to the colors which turtle will recognize. So here's a challenge for you. I want you to create 6 turtles, one for each of the colors in this list of colors. You're aiming for the turtles to all go to the starting line in a distribution that looks something like this. It doesn't have to be precise, you don't have to get it perfectly right, but just make sure that they're sort of evenly spaced out and they are at the starting line. So this is what you're aiming for. 6 turtles, 6 colors, all starting at the starting point along a different point on the y-axis. Pause the video and give that a go. So we know that in order to create lots of turtles, we're going to need some sort of a loop. So let's go ahead and use a for loop to say turtle index, and we're going to create a range to specify how many turtles we need. Our range function will go from 0 to 6. And remember that the range function actually doesn't include the number 6. So we'll create a range from 0 to 5. And once we've done that, then we can indent this block of code so that we create 6 turtles. But at the moment, they're all going to the same position. So how can we change this? Well, we want the X position to always be the same for all the turtles because the X position is along the horizontal axis and we want all the turtles to start at the starting point. Nobody gets a head start. But the Y position is the thing that we want to change. A really simple way of doing this is to simply create a list of Y positions. And you could work out some sort of reasonable position that you want to take. So let's say we start out at -70 and then we just increase by 30 each time. So then that becomes -40 and then -10 and then 20, 50 and 80. So it's roughly distributed somewhere along the middle. Now, instead of using this Y position, which is hard-coded -100, we're going to take the Y positions and then pass in our turtle index, like this. So now when we rerun this code, you can see that for each of the turtles, they're all going to get an individual Y position, and they're all separated by 30 in distance. Now that we've got our turtles neatly lined up at the starting point, the next thing is to give them a different color. So we're going to use the list of colors and then picking out the color using the turtle index. So now we should get some multicolored turtles, and it'll be much easier to bet on a turtle. So now that we have our turtle race all set up and ready to go, the next step is to actually get the turtles to start moving. But before we can do that, I really want you to get a good grasp of how the coordinate system works in Turtle. So in the next lesson, I've got a quick quiz for you just to make sure that you really understand what's going on here. In the last lesson, we figured out how we can get our turtle race up and running and get our turtles at the starting positions. Now, the next job we have is to figure out how we can get these turtles to start moving. The movement is going to have to be randomized, and each step they take will have to be a random number. That way they don't go straight to the end and we end up with a terrible gaming experience. So what we're going to do is we're going to create a random number, let's say between 0 and 10, and then we're going to tell the turtle to go forward by that random amount, so it could be anywhere between 0 and 10. And then we're going to get this to repeat itself many, many times. As you might have guessed, this is probably going to involve some sort of while loop. So let's say we start out with a variable called isRaceOn, and it starts out as false, but then once the user has made their bet and we can check to see user bet exists, then in that case we're going to switch that isRaceOn to true. And then we can use our isRaceOn inside our while loop. Now this way we prevent our while loop from starting up while the user is still deciding on which turtle they're going to bet on. so it doesn't start prematurely. Now, when the user has made their bet and the race is now on, well, now we're going to need to get hold of a random number. So we're going to use the random module to get hold of a random int between the range of 0 and 10. Now, rand int is actually inclusive, so the random number could be 0 all the way up to 10. So now we're going to call this the random distance. And this is going to be the distance that one of our turtles is going to move forwards by. So we want some sort of turtle dart forward, and the distance that it goes forward is the random distance. Now, we have lots of turtles that we've created, but we kind of haven't really done anything with them. What we want to do instead is to have some sort of list of turtle. So we'll call all turtles. And this list starts out as empty, but every single time we create a new turtle, then we can append that turtle to this list. So at this stage, it doesn't really make sense to call all the turtles Tim anymore, right? Because they're all going to be individual instances. So let's go ahead and refactor and rename this to a new turtle. And now what's happening in our for loop is we're creating a new turtle, and each of those new turtles are going to be appended to our all turtle list. So now we're going to have a list of multiple turtle instances. And each of those instances is going to have a different state. So for example, they already start out with a different Y position and a different color. But later on, we're also going to get them to move forwards by a different amount. So we can loop through our list of turtles. So for turtle in all turtles, let's go ahead and create a random distance for each of them and then move that turtle forwards by the random distance. So now if we run our code and see it in action, you can see that once all of the turtles have gone into their starting positions, they start creeping along each time by a different amount. Now, however, our turtles are actually going to keep going until forever. It's basically a loop that's never going to stop. So let's think about what the stopping condition should be. Well, once any of these turtles have actually reached the end of the screen, which is the X value of positive 250, once they've reached this line, then that's kind of the end of the race, right? But a turtle object is a 40 by 40 object. So if we're only detecting for the 250, then our turtle would have already overshot. So instead, we want to detect when the turtle has reached the 230 mark. Back in our code, in our for loop, we can check to see if the turtle that we're currently looping through, if its X coordinate is greater than positive 230, well, in this case, it's basically 1. Now, at this stage, if we print this current turtle's color, then you'll actually see something a little bit strange. You can see that firstly it prints multiple values because the while loop is still continuing and the other turtles are continuing to go forward. But the first value is going to be the turtle that won. And you can see it prints yellow and yellow. So what's going on here? Well, if we look at this color method, you can see that you can either use it to set the pen color and fill color, or it will return the pen color and fill color. So when it prints out two colors, the first one is going to be the pen color and the second is going to be the fill color. So if we only want to know the pen color, then we can just get hold of the turtle dot pen color. This is going to be the color of the body of the turtle. So in our code, we can say that the winning color is equal to the current turtle dot pen color And then we can now check to see if the winning color is equal to the user's bet. Because if this is the case, well, then the user has won, right? So we can tell them you've won, and then we can tell them the color of the winning turtle. Now, however, if this is false, or rather in the else statement, well, in that case, we're going to have to print the same thing, but now we're going to tell them that they've lost. Finally, when the first turtle reaches the x coordinate, when this first color gets printed, we want to stop the while loop. This way, the remaining turtles don't continue to nudge forward and we end up with lots of winners like this. So inside this if statement, when the turtle's x coordinate has surpassed 230, we're going to change the is race on to false. Now we're ready to test out our code. And again, I'm going to bet on the red turtle. And I'm going to speed up the playback speed of this race when I'm editing this video. And now the game has ended, and you can see that the blue turtle is the one that first got its head across the finish line. And it tells me just as much. I've lost, and the blue turtle is the winner. So we've now used Python Turtle to build a very simple turtle racing game. And we're starting to use these X and Y positions in the turtle coordinate system. Now, these coordinates take a little bit of getting used to, especially thinking about things such as if a turtle is 40 pixels wide, then in order to get the turtle to the starting line, we have to subtract half of the width of the turtle, which is 20. So then 250 minus 20 becomes 230. And it's things like this that takes a little bit of getting used to. So what I really recommend is to have a play around with these values. Make it smaller or make it larger, change the size of the screen, and just until you're really familiar with how the coordinate system works before you proceed to the next lesson. Because as you keep going, I'm going to presume that you've already had a play around with it and you know exactly how it works. Now, the other thing that we saw a lot of in this project is this concept of having multiple objects created from the same class. So in this case, we're using the turtle class to construct a turtle object called Timmy, but we've also got a separate object called Tommy. And Timmy and Tommy are both turtle objects, but they are different instances. So they can act independently, they can have different appearances, they can have different colors, different attributes, and also a different speed of movement. So we've seen in our turtle race that each of these instances can act of their own accord and have different state. And that's shown in the different speed of movement. And this capability of creating multiple objects which can act and behave independently is really the secret to why object-oriented programming can be so powerful. We can create so many of these objects and get them to do our bidding in various parts of our program. And in the coming lessons, as we build more and more complex projects, you'll see this concept of having multiple instances with different state being shown again and again, and we're going to come to see and enjoy the benefits. Hey guys, well done on completing day 19. Now, at this stage, you might already be at the point where you're thinking, ooh, I would love to expand on some of these projects. And that is the perfect idea to have. That's exactly what I want you to think. But you might be looking at the solution code that I write and be like, ooh, actually, this solution code is too simple, or like it doesn't catch all the corner cases, or, it doesn't allow me to max out the project in terms of all its features or all of your ideas. But that is because the solution code has to fit within, more or less like a 1 hour or 2 hour time frame. And it has to be simple enough that anybody at this stage should be able to understand as I go through it. So it's not going to catch every single possibility. It's not going to be all encompassing. But what I want you to do is, once you're comfortable with the solution code, once you understand what's going on, and you've got ideas for expanding on the project, then do it. Go ahead and try out to write the code that you want the project to do. Now, this might involve a little bit of Googling, it might involve a little bit of research on your part, and you might also find that, hey, actually, I need to wait until maybe 20 lessons on when I learn more about some other topics before I can get back to this project. But start thinking about how you can expand on these projects, how you can make them better, and don't be limited by my solution code. That's what I want to tell you today.